dt. Tilted it. Come on, man. That looks better. Well, 2 pi is just a number, so that stays 2 pi. And what's the derivative of r with respect to t? Well, that just turns into t over dt.
Yes.
Right? Not too bad. Now, let's hop into number 8. We have 2 variables. Are either one of those time? No, so we have to do implicit differentiation to both of them. But since it's multiplication, what do we also have to do? Product rule. Is this number 8? All right, first thing we got is going to be ds dt equals. I'm going to do 2 pi. 2 pi is just 2 pi. I'm going to do the h first, derivative of h first. So it's 2 pi r. What does h turn into?
dh
over dt, right? Plus, because we do product rule, now I'm going to do the derivative of r. So 2 pi, what does r turn into?
dr over dt.
dr over dt. And we'll leave h alone. Because 2 pi is just a number, right? You could pull out a 2 pi and like factor this, simplify it a little bit, but I'm not too concerned about that. What's that? What's the next one we need to do?
10.
10. Ah, 10's easy. Perimeter square is P for us. Nope. Try it again. So we do derivative perimeter. That's dp over d what? T. Right. I know muscle memory is gonna want you to put over dx, right? Because we've done like all this time dy over dx. So we don't have time, so it turns into 4 what?
ds.
Ds over dt. Not too crazy, right? Not too bad. It's just like we did in the business calculus. It was like, you guys already know how to do the calculus. Let's apply it to business stuff. You guys already know how to do the calculus. We're just now applying it to real world problems. So the example for this one would be, at what rate would the perimeter increase or decrease if I were to increase the side lengths as time goes on? Or volume of a cone. If I were to have like an ice cream cone and the ice cream is melting out of it and it was leaking out of the cone, at what rate is the ice cream leaking out on? Are we gonna do 12? What's the other one?
11, 12, 13, 14.
We didn't do any of those?
No.
Come on.
We got all the way down to like 9. We skipped 8, 10.
All right. Let's do 11. How many variables do I got?
2.
2. Are either one of those time?
No.
No. So it's going to be
Product rule.
dv over dt. We got to do product rule again. I'm going to do the h first. So I'm going to do r squared. H turns into dh over dt. Plus, now I'm going to do the r. I did a big brain move. Pi is a number, right? Why don't you go ahead and factor out a pi and then take care of the rest of it? So could you clean this up and make your work less at the end result? Absolutely. So I didn't even do anything yet. I just pulled out a pi, and then I took a derivative of r squared h, just to make my life a little bit easier. Now this might be helpful for like fractions, or pi, or if you got any other numbers. But let's rewind a little bit, because I did do that a little quick. r squared, kept it alone. H turned into dh over dt. Plus the 2 from the front of the r. 2 minus 1 is r. Don't touch h, dr dt. Chain rule. We good there? Okay. For the sake of just extra practice, go ahead and try and see what you get for 12 for me. Just try 12 out on your own. See what you get.
Real quick question, could you do the same thing in factor?
Absolutely. I'd factor out pi over 3 before I even do anything. So I think I need to get a better microphone, but once I get this ironed out, I think with this new system I'll be able to do is post this recording before even the school day is over, and post my handwritten notes here right next to it. And it doesn't require, I am saving time by doing that. So rather than going home and doing an hour and a half worth of videos every night, I'm tired.
So, if I were to write out the product rule, like, here, can I just write on my paper?
Sure.
So for like the last column, I did that for the second language.
Yes.
So, F1 and then G, but then you have the
So this is like this stuff collects these bills, and this is handicap, and so since I have things coming in 5 minutes, I have it paused. All of a sudden, make it all.
this is DR. Okay. Okay.
It's a chain rule, right?
So yeah, now it's
R squared. So to take the derivative of that, bring the 2 out in front,
Then DR.
and then, yeah, since this isn't x, we have to do the chain rule and go 1 layer inside. Or it isn't t, but sorry. You have to go 1 layer inside.
And then you just squeeze the H in there.
Yep. We good?
Yeah.
All right, before we hop on to a example, let's try 14 out. And if you want to big brain it, what is 14 look an awful lot like? Pythagorean theorem. We're now going to do calculus with Pythagorean theorem. So the derivative of this would be, with respect to time, not x, but time. So that would be what? 2x dx dt plus 2y dy dt equals 0. Okay, we're taking our derivatives with respect to time, not with respect to x, with respect to time. That's the answer. That's it. Now we've, say, brushed up on our implicit differentiation. Let's apply this to a real life situation. The only thing is, we're just going to take these, go one step further by plugging in some numbers, and then we're done.
Okay.
So I say we're already like halfway through the bulk of the problem. The only thing I want you to do is don't freak out. Breathe. Write the information you got, and then we go from there. So we got a function. It tells us dy dt, or we're finding it with dy dt when x is 3, the rate of x with respect to time is 2, and x equals 3. So the very first step we're going to do is differentiate or take the derivative of this function. So what does this turn into? Y equals x squared dy over dt equals 2x dx over dt, right?
Yeah.
Minus 3 dx over dt, right? And it just wants us to find this number now.
Really quick question.
Yep.
So why is it that we're doing the dx over dt? Like when is it specifically that you do the chain rule like that again?
If what you're taking the differentiation or derivative with respect to is not in that variable, so this is t is not x, right?
Okay.
We take the derivative of it, it's dx dt. If it's the derivative with respect to x, so like
Yeah, that's what I was.
y equals x squared minus 3x. If we do y prime, which when we did y prime, we're also saying that's dy dx. So you're taking the derivative with respect to x. That's when you just do the easy stuff,
Okay.
right? But since it's respect to time and we don't have time here, we gotta do the chain. Now, we already done the hard part, because we just need to evaluate now. Evaluate's the fancy words for plug and chug. So we do have to be particular on how we annotate it, though, right? So dy dt evaluated when x equals 3. What else do we know? Is there a typo on this? Dx dt. Oh, we actually don't need y. That's right, because y's don't. Dx dt equals 2. Yep, put them on top.
Or could you put a comma?
I wouldn't put it. Commas would be okay if you're writing like horizontally. I think so. So just plug and check. So it's going to be 2 times 3 times 2 minus 3 times 2. Hey, look at that. It's just algebra. What we get? 6? That's it. We're done.
Yeah. You said you can put like equal sign underneath that equal sign and it'll still.
Yes, you're fine. The only time you can't do this is when I start doing math operations. So let's say, for example, I had what I can't do from here is say right, because it's just you gotta, because they don't know how you got there. Well, they do, but they're gonna assume they don't.
So like simple multiplication like that, they're gonna be like, oh, okay.
If you do the keyword you're looking for is if you do a math operation, you got to rewrite the whole thing. We didn't do any math operations to either side of the equation, so we can just simplify and call that.
A math operation.
Add, subtract, multiply, divide, take derivative.
Oh, it's either side.
Yeah. The generic term for add, subtract, multiply, divide is an operator, so it's a math operator. Okay. All right. Try out number 2. They gave you crazy amounts of room. You don't need it. Well, unless you've got big flowery handwriting. Okay. we're looking at what rate is the total area for a water ripple changing? What is, if we got a water ripple, what equation am I going to use for the area of a water ripple? We're going to look, we need something first before we can take a derivative. If I draw a ripple,
Like a circle.
we need a circle, right?
Circle.
We got a circle. So we're looking for area though. What's the area of a circle function?
It's
That's not gonna be given.
No. Pi r squared. Cool. What else? They give us a piece of information. They say the rate at which the radius changes with respect to time is what? 1. So dr over dt. They give us that number. Equals 1 foot per second. At what rate is the area changing with respect to time? So what do I got to do now? Take the derivative. So this turns into dA over dt equals 2 pi r dr dt, right? Like legitimately, that first page of the notes was like the hard stuff. The rest of it is once you got your derivative, it's all plug and chug,
Oh, and then you just
right? What else are we given? When the radius is 4 feet. So we got our derivative with respect to time. Let's just evaluate it. So dA over dt evaluated when r equals 4, dr over dt equals 1, 2 pi 4 1. I forgot something though. I did boo-boo on purpose.
Units.
Need your units. What's the units for area?
Yeah, that's a good question.
Okay.
is
I'm going to show you how to get this unit foolproof method. Ready?
The center is it like a square?
So let's I'm going to zoom in just a little bit more here. Okay. And I'm going to erase this. You don't need to, but I'm going to erase this real quick. What is the unit that is on R? Well, that's 4 feet, right? What's the unit for dr dt? Feet per second. So feet squared per second.
Oh my gosh.
Oh yeah, story shows up everywhere.
How the heck?
No,
perfect at Python.
no. Units are gonna chase you for forever.
That might be
Sweep
you guys'
was fine.
Python.
I
Actually,
actually
there's that.
What's that?
Sweep was fun.
It's just a puzzle. Once you get it, you got it.
I do like Sweep.
It just takes too
Got my little box. Little table.
Because you had to convert like radians to degrees,
Oh, yeah.
right?
We learned it.
Tire, how many rotations a truck tire does. I hated it.
We learned it in chemistry.
Chemistry.
Now, technically, this is like an actually moment. Actually, the correct word, when you use dimensional analysis, is the correct word. And what we're doing here is dimensional analysis, not technically considered stoichiometry. Stoichiometry is like in the focus of chemistry, but nobody's going to correct you there.
Yeah, like you say it.
Yeah.
Like you say that.
Okay. We feel okay here?
Yeah.
All right, here's what I'm going to do. I'm going to go close that door. I want you to try this. The only thing we need, though, is a volume of a sphere.
That's a good question.
4/3 pi r cubed. Volume volume of a sphere is 4/3 pi r cubed.
Apparently the girls are taking it. According to this children.
Do it. I did.
Damn.
He's not pushing
William's like just shoved the kid into a wall.
Oh,
Wait, guys, is it gonna be D?
You take the derivative of the volume of the sphere.
So it's DV over
dV over dt, yes. What else are we given though?
giving radius is
Cubic centimeters per minute. Oh, cubic centimeters, that's a volume. That's dV over dt.
Oh.
No, because it's cubic centimeters, and anything cubic is a unit of volume, right?
So do we just plug
so you just
that in
plug
for
it
the
in.
other side? Would that work?
What are we looking for? How fast the radius is increasing. So we're looking for dr over dt. We don't know that.
Oh,
We also know that the radius is
30
30 centimeters. So r equals 30. And then we got it from here. Well, at least we should. Should we take our derivative of the volume yet?
is it 4?
d over dt equals 4 pi r squared dr dt.
Isn't it? Oh wait, never mind. Just kidding. You, cause the, yeah.
Hang on.
Cause you can cancel out the threes. When you bring that three out, it cancels out the
Yep.
three.
Oh.
Okay. We're looking for dr dt. Is it by itself here?
No.
No.
Oh, we have to do the thingy.
We just got to do division. dV over dt divided by 4 pi r squared. Now it's just plug and chuck here. Now we're ready to evaluate. So I'm going to zoom. So dr dt evaluated when r equals 30, and dr over d or dv over dt dv dt equals 800. So what's the context of this question asking is, how big is the balloon getting with a certain rate of how much I'm pumping air in? So that's 4 pi 30 squared. I'll be back.
Jenna's hungry.
I'd be broke.
Like you could just get
I'd be broke.
prepackaged sandwiches.
I would be broke.
Like the ones that have the heavy
You know how much money they would make for this?
Yeah, I know. I don't know how you're gonna do that.
Oh, made McLaughlin.
I mean, he probably does. Because
He does.
What are you looking at? Is that even like?
I've been in
Right.
Well, yeah, but
Right. I mean, for real. sure
for
they're
him though.
aware of this.
I know. It's good though. Good for him.
If you figure out this last she's not mad, I can put it
Look, you need that.
We get a simplified answer yet?
Hold on. Sorry.
Two ninths over pi. Two over 9 pi. 2 over 9 times pi? It's not the same. Because pi is on the denominator. What's... Yeah, so I... So I've got 800. 30 squared is what?
It's
900.
900.
yeah.
9, well, it's 9 times 4. So I got 4 times 900 pi. Actually, no, let's also do my units in there while we're at it. What's the unit for radius?
Centimeters.
And we squared it, so it turns into centimeters squared. Right?
Yeah.
And then I still got a pi here. What's the rate unit?
Centimeters cubed.
Per minute, right? What units cancel out?
Oh. Centimeters squared.
Centimeters squared.
I was getting that.
You got there. We started with centimeters. Centimeters squareds cancel out in centimeters cubed, so what are you left with on top? Centimeters per minute. Cool. Now let's look at our number. 800, well, first thing I would do is I'd just cancel this out, because that would be 200 over 900, right? So I'll just 200 over 900. And then you can take out the zeros as well, right? So if it's just 2 over 9. 2 over 9 pi centimeters per minute.
I love that they gave us whole pages to do this.
I know I believe this.
They're being so good.
Okay, we got a ladder up against a wall. Draw a real quick picture. Maybe we can see what formula we're going to need. It's going to be Pythagorean theorem. Sure will. What letter would you like to represent the vertical up the wall? Don't overthink it. Think of it.
H. How can we get a variable?
Oh.
Twice up.
Oh.
X is over. And then 25-foot ladder, so this is 25. So what's our equation? X squared plus y squared equals 25 squared.
625.
625.
I don't remember why I did that.
I don't know why, but I just feel like 625 squared should be a bigger number, right?
Yeah.
I don't know. If I had 25 25s,
No.
I just feel like it should be
I
more.
thought 30 was gonna be a lot more. 900. That printed out was like.
Okay, well the top of the ladder is 7 feet from the ground, so when y equals 7, what is the rate of change from the distance from the bottom of the ladder and the wall? or no?
with 3 feet per minute.
3 feet. It's sliding down vertically, so we know dy dt equals 3. Right? And that's feet per minute. Feet per minute. Bless you. That's 7 feet. Just throwing units in there so we can do our unit and easy. We're looking at rates. First thing we do when we gotta look at rates is 2x dx dt plus 2y dy dt equals 0. What are we looking for?
dx over dt.
Dx over dt, so I'm going to get that by itself. So dx dt equals negative y dy dt.
Can we figure out x,
Well,
What's that?
y, alright, that's going to be 2x.
Where the
2 cancels out, and then I need divided by.
Okay.
Can we show the other one? I'll show.
Yeah. Don't we have to find out x too? We have 2 variables right now. We can find it out since it's a triangle. We can just do.
Yes. But
Okay, yeah.
I just got ahead of me, so that's all it was.
Sorry, I was just.
You're fine. Here's big brain it. Think of it. So first thing I'm gonna do is subtract this to the other side. So what I get is 2x dx dt equals negative 2y dy dt. Right? 2's cancel out. Gotta divide by x now. So dx dt equals negative y over x dy dt. Now, which I was getting at where we don't have a value for x yet. Could we find one?
Yeah. It's 24, by the way.
Like that one guy on TikTok. Just do it. Don't make it hard. Seven squared. 625. 625 minus 49. The square root of it is
576. 24.
just going 24. And that is feet. Yes.
Oh, that's how we got
Now we can evaluate, right? Because we got all our pieces. Evil number?
that. Is that just a Y? I got messed up.
Yeah.
Okay.
Sometimes I write just a little too fast for the board to recognize what it is.
I'm just making sure I didn't miss.
Can I evaluate this now?
Yes, sure.
Sure can. So we got dx over dt evaluated when y equals 7, right? X equals 24, and what's the other number we got? dy over dt
3.
is 3.
Wait, where did we get X?
The diagram 0.
That should be a negative 3. It's slide down the wall. That's my over there. Slide down the wall. It's not going up the wall. Slide down the wall. Negative 7,
Oh, I could.
24, negative 3. So we get what, 21 over 24, which simplifies out to 7/8, right? What's the unit?
Oh, hang on. 8 divided by feet. Oh wait, see that? Times. Feet per minute.
Feet per minute. You could do the stoichiometry and try and do all the cancellation, or what's the units of x? Feet. What's the units of time? Minutes. Feet per minute. I'd love to hear that statement.
Take how much went down.
Okay. Now, does this make sense as far as the scope of the question? If the ladder slides down from the wall, it should slide away from the wall, right? So our rate here is negative to slide down the wall. Our rate here is positive, sliding away from it. Right? Cool. Right? It's just understanding the context of why we do implicit differentiation on these problems. There's one of them here we're skipping, and that's example 5. Just put a big old, because she's doing bad physics, and it irks me to no end. This time they give you the formula.
Aw. So sweet of them.
They give you the formula. All right. All I want to do is maybe give you guys a couple minutes to try this one out. Okay.
took
Should be negative.
Wouldn't it be negative
Oh, I
96?
That's why I
forgot
got-
something.
So it'd be negative 60.
I did a boo boo.
Like,
I did a boo boo.
Yeah, I didn't figure out the units,
Did I do a boo
I'm
boo?
working on that.
80.
I think inches squared per second.
Come on.
If I get this right, I might.
So that would be 96. Yep. Now we're looking at change in volume, change in time.
Because the rate,
So if it's like change in volume, do we always know that the like inches or feet or meters or whatever's gonna be cubed?
Because linear dimensions cubed, yes. But what if the volume was in units of liters or milliliters? Okay.
So how did it do? Oh, it's volume?
Mm-hmm.
Okay. Another question. Can you explain how you got the units on the last one? Cause I thought it would be feet squared per minute.
Well, it's change in x over change in t, and x is measured in feet. We did square the term, but the units for x are in feet still.
I just thought since like, I have it. Since that 87 feet,
That's feet over feet still.
oh.
You get another foot in there.
Wow.
Crazy how that works.
Okay.
It's the classic joke. You can't break math, but math sure can break you.
That's true. That's kind of cool though.
We feel okay on this one?
I can ask for not.
Yeah.
So I just don't get the unit thing, where in the, I just don't get,
How do we pull this out?
why can't it just tell us what it is?
Well, what's the units of volume given in the question?
Inches cubed.
Inches cubed.
So then where's this at?
So, this is back to like, let's see if I can zoom. Let's do that. There we go, that's what I want to do. So, what do I have? We've got linear dimensions. So like height is in inches. Area is inches squared. Volume would be inches cubed. That's one way to pull that out. However, another way to pull it out, because people love to do the stoichiometry dimensional analysis method, let me redo my numbers here, but include the units as well. So, all right, we've got pi. This is radius, right? Actually, let's just erase this. I got a bigger razor, please. Like this. Can I do that? It erased the only thing I didn't need to erase. Maybe just like slice through it. Like Fruit Ninja style. There we go.
Fruit Ninja.
So let's rewrite this with our units in there. So dv over dt equals, pull the pi already. What we got? 4 is our radius, so let's do 4 inches squared times 5, which is d, it's supposed to be 5 inches per second. And that's from up there in the question. It looks like sine per second, that's 5 inches. Plus 2, so number 2, times 4, which is 4 inches, times 6, which is 6 inches, times, what else? The negative 2 inches per second. So on this unit on the left-hand side, inches squared times inches, right, it's both on the numerator. Well, that gets me 16 times 5, which is 80, so it gets me 80 inches cubed per second. This turns into negative 96. Well, what do I have? I've got inches times inches times inches. Inches cubed per second.
Just because you're subtracting it, you don't have to.
Yeah.
You're multiplying them again.
Correct.
Wow.
Negative 16 pi inches cubed. What do you do, Emerson?
You said Fruit Ninjas, so I had to download it real quick. Can't get online. It's pretty fun.
Okay. We're skipping example 7. Let's do example 8 and be done. Yeah. First part of this question, part A, is the longer, tougher part. Part B is a nice short part. Okay. Actually, you know what? We'll just save that for tomorrow. We only got 5 minutes. It'll take more than 5 minutes to do.
Oh my gosh.